Greetings and welcome to today's webinar, Fundamentals of Data Exploration and Visualization in R. I'm Sarah Pennebecker, Assistant Director of Alumni Relations at the School of Public Health. Thank you to all alumni, students, and friends of the School of Public Health who have made time to join us live today. Today's webinar is a special preview of a course available to you through the Public Health Institute this spring. Webinars like this one are a chance to hear about new classes offered at the PHI directly from the faculty who are teaching them. Get a first look at these new classes and then sign up to participate. Whether you're joining us because you're curious to learn a little about the topic or checking out if this class is right for you, welcome. We'll touch on how to register for the course at the end of the webinar. Questions are welcome and you may submit them at any time. Please type in your questions in the questions panel on the right-hand side of your screen under Q&A. We'll be monitoring questions along the way, so please submit your questions or comments at any time. And now to the webinar. First, I'd like to introduce our presenter, Julian Wolfson. Dr. Wolfson is an Associate Professor and Director of Graduate Studies in the Division of Biostatistics, School of Public Health at the University of Minnesota. Dr. Wolfson's research lies at the intersection of causal inference and machine learning, particularly as it applies to large, messy data sets. He applies methods to problem solving, such as finding surrogate endpoints in clinical trials, identifying relevant explanatory variables in the presence of correlation and measurement error, predicting the risk of heart attack using electronic health record data, and understanding human behavior patterns using smartphone sensor data. His collective work spans multiple disciplines, including neurology, infectious disease, cardiovascular health, nutrition and obesity, and pediatrics. Dr. Wolfson is a past recipient of the Leonard M. Schumann Excellence in Teaching Award from the School of Public Health and has been using R for over 15 years. Welcome, Dr. Wolfson. We'll turn over the webinar to you.
All right, thanks very much. Welcome virtually to everybody who's listening. So I hope today to give a little bit of background on the motivations for this course, how it's going to be put together when I teach it at the PHI, and then a little bit of a small taste of some of the topics that we'll be covering. So I want to start by giving a sort of an overview of R and why we might want to learn it. So R is a statistical programming language that can be used to do a bunch of stuff. Read, clean, summarize data, fit models, prepare visualizations, create interactive web applications, and many, many more things. Now, some of you who are listening to this webinar and might be interested in taking the course are possibly familiar with other statistical software packages like SAS, Stata, S+, etc. R is a little bit different from those packages because it is really fundamentally a programming language rather than a system designed purely to carry out sort of statistical analyses and do data manipulation. I was trying to think of a good metaphor for comparing R to these other statistical software packages, and the best thing that I could come up with is that if you're using SAS or Stata, it's like you go to the store and buy a Lego set that is specifically designed to construct something like a rocket ship or a model of a farm. The pieces are very explicitly designed and very tailored to do that particular thing, but you're going to have trouble building more than that particular object with the pieces that you have in the box. R is a little bit more like going to the Lego store at the Mall of America and having access to all of these different pieces that can be combined in a whole bunch of different ways. The power of R is that if you want to build, say, for example, a 30-foot tall transformer out of Lego, there's no off-the-shelf kit that can do that, and so you're going to need to use something where you can start from those basic building blocks. And so R provides some of those basic building blocks. So one of the advantages of getting into R programming, in addition to sort of supplement any experience you might have with SAS or Stata, is it really allows you to expand the universe of things that you can do with statistical programming. So I've given a little bit of a motivation already for why you'd want to use R, but there's a few other things that I wanted to mention. R, one of the big pluses that you probably know is that R is free, completely free, open source, can be downloaded straight from the web. And as a result, a lot of different people in a wide variety of constituencies use R, and many of them are online and are engaged in a very large and generally quite supportive user community. So there's extensive online help available, and this is help that is not created by the R project, the people who distribute R. It is help files, answers on web forums, things that have been just generated, created, and are curated by people using R. So the availability of this massive sort of online help support system is actually one of R's biggest benefits. I frequently find myself not knowing how to do things in R, and when I want to find out how to do them, I Google, how do I do, X in R into Google, and 95% of the time I come across some online help article that specifically answers the question that I want to answer about how to do that. So it's very nice to be able to fall back on that online resource when the documentation of the package itself might not be available. Speaking of packages, again, because R consists of all these basic building blocks, people have assembled these building blocks into a huge number, over 10,000 downloadable packages that extend the basic functionality of R. And these packages range from really sort of trivial things, like, for example, there's a package that will play the Super Mario Brothers theme song, for example, up to very, very sophisticated packages that allow you to interact with a whole bunch of different kinds of databases or create very sophisticated interactive web applications. It really runs the gamut in terms of how these R packages are built. But all these packages, all these add-ons are also available for free and are generally quite well supported by the user community. So a very extensible, broad system with really sort of infinite possibilities. So as I mentioned briefly before, R is used by a huge number of different constituencies. The primary constituency of R originally was academic statisticians and biostatisticians like myself. I started using R in 2004, which was when it was kind of starting to reach maximum popularity in the fields of statistics and biostatistics. But in the past 10 or 15 years, it has really gained a foothold in a wide variety of other domains. It's become quite popular in other academic disciplines like economics, psychology, biology. It's gained a lot of foothold in the public sector. Obviously, being free and open source is a big benefit there. There's a lot of work that's being done with sort of public access data that's being done in R, and then also in private industry. And that ranges from sort of the modern data science-y type of companies. So, for example, Airbnb does a lot of their internal analytics work in R using a bunch of sort of interactive applications that were created sort of custom for their company. Places like the New York Times and 538 do a lot of their data visualization using tools that are created in R. And so we see R really reaching to a lot of different spaces. So this comes down to the question of why you would take this class. There's a few reasons why you might. You might have heard about R, but have never used it, and you'd like to learn how to use it, in which case, great. I think this class is for you. If you've had a bit of experience with R, maybe you've run a few models, but you haven't really done anything substantial in it, and you'd like to learn how to use R better, great, this class is also for you. You might also really like Hadley Wickham. I'll talk about Hadley a little bit later on, but this dapper gentleman here is the author of several of the main R packages that we'll be discussing in the PHI course. So if you really, if you like looking at Hadley, or you want to meet Hadley, for example, sometime in the future and be able to have an informed conversation with him about the tools that he's built, then this would also be a good opportunity for you as well. So since Hadley is not teaching this course, you have to decide why you would take this class with me. Well, I do have quite a bit of experience using R. I've been using it for over 15 years, which makes me feel old, but at least I guess does give me some amount of background to be able to convey some knowledge. And so not only have I used it for 15 years, but it is something that I use on a daily basis. So it is really something that I am constantly using, constantly learning about, constantly teaching myself new things in. And I really enjoy the process of teaching myself new things in R because I think there are some people in academia who use software, but they view it as a bit of a pain. They'd rather not have to spend their time with software. But I actually really enjoy the process of programming and data visualization. And so part of the reason I wanted to teach this course was to be able to share that passion with people who also wanted to learn how to do that. I also care a lot and think a lot about how to teach well, which I think is important. I put a little note here to mention the Leonard Schumann Award, but my thunder got stolen at the beginning of the intro, so maybe I'll just I'll keep going. I'll keep going there and leave out that parenthetical reference. All right. So what are we going to talk about in this course? Well, the goal of this course is really to give students the tools they need to do non-trivial data manipulation and visualization tasks in R. So I want to get people going as quickly as possible onto skills that they will actually find useful in what they're working on. So I have here as the number one thing that we'll be learning basic R syntax, but I will try to spend as little time as I can on basic R syntax in the interests of getting on to items numbers 2 and 3, the data manipulation skills and the data visualization skills. So with respect to data manipulation skills, I'm going to be talking about using something called the dplyr package, D-P-L-Y-R. And I'll talk a little bit later about dplyr and give you a little bit of a preview of how dplyr works. But dplyr is an add-on package to R that doesn't come with the base R distribution, but that I feel gives students who are just starting to learn R a much better foothold on how to do data manipulation than trying to teach sort of base principles from the base R language. So I made an intentional choice here to teach using dplyr for data manipulation because I think it allows students to get up and running with doing real data manipulation, the real-time types of data cleaning skills that you would like to be able to do. It allows you to do that much more easily than trying to learn all of the R syntax that you would normally have to do in order to do that kind of data manipulation. And again, if you're familiar with SAS and Stata, I think that SAS and Stata have generally done a fairly good job of creating syntax and creating ways to do data manipulation, for example, that are relatively clear and sort of fit for purpose for the types of things people want to do. But there's a lot of other overhead that goes along with that in SAS. And one of the purposes of the dplyr package in R is to replicate that same kind of simplicity, but to pair that with the power and flexibility of R. So the third thing we'll talk about is data visualization skills. And again here, I'm choosing not to teach using the base R tools for plotting, which themselves are fairly powerful on their own. But the ggplot2 package, again, is, I think, a very powerful way of learning how to do plots. And the big benefit of using something like ggplot2 is it allows you very quickly to move to creating very visually appealing, interesting, dynamic plots much faster and requiring much less effort than using the base R tools. So the choice to use dplyr and ggplot was really driven by the desire to get students doing things that are useful as quickly as possible using these tools. Now, an overarching goal of the course is also to try to instill this amorphous concept of good programming habits. So what does good programming habits mean? Well, it covers a lot of different things. But basically, the goal with good programming habits is to make your code easier to read and understand for other audiences. Now, one of the points that I make in class and that I'll make here is that oftentimes the most important audience for your code is your future self, right? When you come back and look at your code in 6 months or 1 year, it is going to be much easier for you to work with it and improve on it and continue developing it if you have written it in a way that is clear and concise in the first place. And so by trying to teach things like dplyr and ggplot, my hope is that you will acquire some skills needed to code in a way that is sort of efficient and makes clear what your intention is in your code, and so you don't just end up with a big mess of lines of code that you have no idea what they mean when you come back to them 1 year later. So we'll talk a little bit about how to make sure that our code very clearly signals what it is trying to accomplish. Now, since the PHI is only 15 hours, there's obviously a lot more in R to learn than can be possibly conveyed in 15 hours. And so there are some things that we're not going to learn. I want to kind of highlight some of the things that you might expect to think about or to learn about in an R course that I'm explicitly not going to be covering or talking about. So I'm going to spend very little time talking about base R methods for data manipulation and visualization. So as I said, there are techniques that are available in the standard R language toolkit for doing manipulation and visualization. But in the interest of getting students up to speed and doing useful things as quickly as possible, I will be mostly not talking about those tools. Second thing to mention is that this course is not a course about how to fit statistical models or to perform statistical tests in R. So there is actually relatively little kind of traditional statistical content in this course. My view is that a lot of students, a lot of people who would like to use R would like to use R to do things that occur prior to or in conjunction with statistical analyses. So they need to learn how to organize their data in the right way to do an analysis, or they need to be able to do data visualization in order to see whether a particular analysis might be appropriate. So you can kind of view this course as providing the tools to give you the precursor to put your data in the right shape and to look at your data in the right way so that you can eventually move on to fitting statistical models or performing statistical tests and on. So it's not targeted at learning how to fit linear regression models or how to do a t-test in R. That's not the purpose of what I'm going to be teaching in the course, but it's to give you the tools that you need to get to the place where you can do those things. And then, of course, there's a whole host of advanced tools and skills in R that I won't be covering. Things like how to write functions to do your sort of own custom data manipulations, how to use R Markdown, which is a very powerful tool for documenting your workflow and to write sort of coherent documents that include both code and results. Or Shiny app. Shiny is a tool that's built into R that allows you to create really compelling, interactive, web-based visualizations using R and leveraging all the power of R, and that you can distribute broadly. But we're not going to be talking about those just because we're not going to have enough time to cover those topics. So a little bit about the course structure. As I mentioned, the PHI consists of 4 sort of full afternoons of instruction. And the way that I'm going to organize these class sessions is to very much not lecture at people for 3 or 4 hours consecutively, because I can think of little that is less interesting than being lectured at about programming for 4 hours in a row. So what I'm going to try to do is break these things down into relatively digestible chunks, alternate between relatively brief lectures covering sort of small topics, and then guided programming activities where you'll actually have hands-on opportunity to do exercises and to practice what you've been learning about. In terms of the technology that's going to be available, the classroom will have computers with all the necessary software tools installed, so the class will take place in a sort of traditional computer lab. But some students prefer to bring their own laptop because they have their own environment set up and they're comfortable working in that way. So either one is workable. Homework is basically going to be an extension of in-class activities. So the same kinds of skills that you're practicing in class will be reinforced by some small homework exercises that will be sort of taken home, and so you have a chance to kind of spend a little bit more time, maybe do a little bit more of an extended version of the types of exercises that you'd be working on in class. So the coverage of the material, I mentioned kind of 3 basic topics. Here's the basic plan for laying those things out over the 4 days. We'll start with, on the first day, with an introduction of some of the basics of R, move on to data manipulation, introduction to dplyr. On the second day, we'll sort of continue with some of that and then move on to some visualization. On the third day, we'll probably wrap up the visualization piece. And the last, maybe day and a half to day and a quarter or so will be spent around the final project. So a couple of words about the final project. My idea for the final project is that I want to give students in the class an opportunity to apply some of the skills that they've learned to data that they might care about or might be passionate about. So this might be data that you are working with in your job. This might be data that are publicly available that touch on a topic that you think is very interesting. But the idea is that you'll have this final mini project where you'll have a little bit of time to kind of decide what you want to do, and then you'll use these data manipulation and visualization tools to apply them to these data. And then on the last day, give a very brief presentation, maybe 5-minute presentation about how you've done some very basic processing or visualization of these data that are interesting or important to you, and present those to the class. So it's an opportunity for a little bit more of an expanded hands-on activity, and often students can get very motivated and to use these tools to do things that they may not have been able to do with the tools that they had at their disposal before taking the class. Okay, so now I'm going to transition to giving a brief preview of some of the tools that we will actually be discussing. So I've got a few slides here talking about dplyr and a few slides talking about ggplot. So just a quick introduction and illustration of why these tools are powerful. So dplyr is a package that provides a set of commands for data manipulation. It was developed by Hadley Wickham. So Hadley Wickham, by the way, I didn't mention when I first showed his very dapper picture, is that he was a professor at Rice University of Statistics and is now the chief scientist of RStudio. So RStudio is the main software that is used by the vast majority of people who work with R on a regular basis. And so Hadley is kind of the closest thing that we have to a celebrity in the R community, and has developed several really fundamental packages, including dplyr and ggplot, which we'll be using in this course. And he's developed a number of packages that are all grouped into what used to be called the Hadleyverse, but which he very humbly has refused to call the Hadleyverse and refers to as the Tidyverse. So the idea for using dplyr, the reason to use dplyr and the motivation behind it is to make manipulating data easier. And so when we talk about that, really what that is going to do is it's going to hopefully make the code that you write to do data manipulation easier to interpret and to read. And hopefully what that means is when it comes down to other people either making changes to your code or the future you making changes to your code, it is much easier to do because you can understand very clearly what the goal of the code is. Now, one thing to mention about dplyr is dplyr does not provide tools that are any different than the tools that you have in base R, in the sense of there is nothing you can do in dplyr that you can't do using base R. What dplyr tries to do is to make those same tasks much easier to code up, so that your code is much simpler and much easier to debug. So dplyr works by providing a set of core functions, which it calls verbs. So verbs are things you do to data. So the core functions of dplyr are the filter command, arrange, select, mutate, summarize, and group by. And these things do more or less what their names would suggest. Filter selects subsets of your data that meet a condition. Arrange orders by the values of a variable. Select particular columns from your data. Mutate will create new columns based on existing columns in your data set. Summarize will create a summary of data values across groups, and group by allows you to group the data by category. So these are very commonly used manipulations when you want to do data manipulation. And so the idea of dplyr is to give you a specific command that does each of these separate things and can be combined together to accomplish those things. one of the powerful things about using dplyr is combining dplyr with this percent greater sign percent operator, which is called the pipe operator or chaining operator. And what this operator allows you to do, and I'll give an example in a minute, is it allows you to string together multiple data manipulation commands in sequence. All right? So what that means is you can take the result of doing one data manipulation and immediately pass it in to another data manipulation and do all those data manipulations in sequence. And one of the biggest benefits of using this pipe operator is that you do not need to create a bunch of separate data sets that represent each stage of your data manipulation. So frequently when we do data manipulation, if our data manipulation involves multiple types of manipulations, if we're using other statistical software packages, like for example SAS, oftentimes what you'll have to do is you'll have to create a data set that represents this intermediate step in your data analysis, and you'll have to save that data set and have it hanging around in your workspace. And you're never actually planning on doing anything useful with that intermediate data set. You're only going to use it as an input to other steps of your data manipulation process. So what using the piping operator allows you to do is get rid of storage of any of those intermediate data sets and have a very nice kind of tip-to-tail sequence that allows you to go from your original data to the final product that you're interested in actually using without cluttering up your workspace with a bunch of sort of intermediates that aren't ever going to be used in any meaningful way. And so as a result, it also means that your code is much easier to read, fix, and reuse because you can see very clearly that this data manipulation consisted of the following 6 operations that were applied in this order. And it could become much more expressive and easy to understand what you're doing. So very quick illustration here of how dplyr can make your life somewhat easier. So some of you might be familiar with the American Time Use Survey, but just to give a very, very brief overview, the American Time Use Survey is administered to several thousand people every year, and it asks these individuals how many minutes they spend doing a whole bunch of different activities during one 24-hour period. Okay, so the data essentially are arranged with 1 row per individual, and then we have 1 variable for each type of activity that that individual performs, and in that variable, in that column, is the number of minutes that they spend doing that activity during the 24 hours that they're reporting their data. So here's an example of a data manipulation task that somebody might ask you to do. Somebody says, okay, give me a table arranged by 10-year age intervals, all right, between the ages of 20 and 80, and I want you to have that table sorted by the mean daily hours worked among females who worked at least 7 hours per day. So we're going to take 20 to 30-year-old females who worked at least 7 hours per day and get the mean daily hours worked. And we're going to do the same thing for 30 to 40-year-olds, 40 to 50-year-olds, 50 to 60-year-olds, 60 to 70-year-olds, 70 to 80-year-olds. So when we think about that data manipulation task, it's certainly not a tremendously complex data manipulation task, but it's not entirely trivial. And at the very least, it sounds like a bit of a pain to code up because you think, okay, well, now I'm going to have to separate my data into the subset of women between 20 and 30 and 30 and 40, et cetera, et cetera. And so if you want to do that, it seems like a bit of a task. And then if somebody says, oh, actually I want this to be done in 15-year age intervals rather than 10-year age intervals, well, now you'd have to go back to your code, recreate all these different subsets of the data, recompute everything. And so doing that seems like a bit of a pain to do. Now, dplyr makes this task a lot easier. I'm going to show you the dplyr code that performs this exact manipulation. So this slide shows you the entire dplyr code for data manipulation that is necessary to produce the table that's on the bottom right. So that table on the bottom right is exactly the table that we wanted to produce. It has the age categories and 10-year intervals. It has the number of hours worked per day for females who worked more than 7 hours. Okay, and the code is actually quite explicit and quite evocative about exactly what is being done. The first step is a filter, which means we subset on females. The second step is a mutate, which means we create a new variable to indicate people who have worked more than a full day. We create the age categories. We then filter again based on whether people worked a full day. We group by age categories, and then we calculate a summarize, where we summarize the mean number of hours worked, because the output here is in minutes, we have to divide by 60, the mean number of hours worked, and then we arrange that in descending order, right? So really we're looking at essentially 7 lines of code to accomplish something which I think in a lot of other software systems, or even using base R, would probably be more like 20 to 30 lines of code and would take a lot longer to write. So this is kind of showing some of the simplicity and the power of using this dplyr framework to do data manipulation. So a few words now about ggplot. So ggplot, why GG? Well, the GG in ggplot stands for the grammar of graphics. The grammar of graphics is an idea that's been around for about 20 years, but it was popularized by Hadley Wickham once again via its adoption in the ggplot2 package. So the grammar of graphics essentially views visualizations or plots as being composed of several distinct pieces. So you've got the underlying data is one piece. The next thing you have are aesthetics. Now aesthetics determine which data points are displayed and what their properties are. So basically the aesthetics of a plot are what goes on the x-axis, what goes on the y-axis, what color are, what determines what color the points are going to be, what determines what size the points are going to be, what determines what shape the points are going to be, et cetera, et cetera. So those are all the aesthetics. What maps to what is the idea of an aesthetic. Then you've got geometries. So geometries determine how the data points are going to be arranged or summarized. So when you think about a set of data points, they can be grouped and aggregated in a number of different ways. You can aggregate data into box plots, into histograms, into densities, etc. And so the idea of ggplot is to kind of separate out the idea of deciding what your aesthetics are, so which variables are going to be included in your plot, and then the idea of how they're going to be summarized and displayed graphically using things like block box plots, histograms, densities, etc. And then, of course, you've got the other stuff, which is all the other plot formatting that you do with legends, axes, backgrounds, etc. But ggplot handles a lot of that stuff by default for you, so that you have to do a minimal amount of tweaking after the fact to your plot. So here's an example of a very simple ggplot. So what I'm doing here is I'm taking my HUS, my American Time Use Survey data, and what I'm going to do is I want to create a histogram showing the distribution of the number of minutes spent in 2 different activities. The 2 different activities I'm looking at here are food preparation and general household activities. And I want to separate out those histograms by sex. So the way that a ggplot works is that the first thing you do is you set up this ggplot object using your data, and you set up your aesthetics that says, okay, I want the x-axis to represent minutes, and I want the color to represent sex. All right? But once I've done that, I'm going to now show you over the next 3 slides how you can use that same fundamental object, and all I'm going to be doing is adding different kinds of geometries, different kinds of ways of visualizing and summarizing that data on top of that fundamental object. So here what I'm doing in this first slide is literally adding, using the plus sign, a histogram. Right? So I'm going to add a histogram to my basic data object, my basic plot object. And then what I'm going to do is I'm going to separate out that histogram into 4 panels where I'm going to separate by sex and by activity category. And so that's going to create this 2x2 grid automatically. And the bottom 2 things with the limits are really just playing with the limits to make this a little bit more visible. So all I've done is taken the fundamental plotting object and added this histogram thing and this grid. Okay? So now we get histograms in each of these 4 separate groups. Now, I'm going to keep the underlying data object the same. This G is the same underlying object that I defined before, but now what I'm going to do is I'm going to use a density to summarize the distribution of the time spent in these different activities. So a very small modification to the code, which is replacing histogram by density, right? And now instead of subsetting for each of the 4 things separately, I just want to separate out by activity type, which means we will show the densities for males and females on the same plot, we get this plot which shows somewhat different information, even though it is summarizing the same data. And lastly, if we don't want to show the entire data distribution, but want to summarize the data distribution using something like a box plot, again, we use the same underlying plotting structure which contains the data and says that we are going to be summarizing the number of minutes. But now we add a box plot. Okay, we add a box plot, and and all the stuff that comes after that is really just basic aesthetic manipulations, right? So we're setting the palette, the color palette that we set these boxes to. We're allowing the theme to change to be dark, and we're changing the X labels and Y labels. But these are all very, very different plots that you can see can be created very quickly using the same underlying data generating object and only require a couple of lines of code. So this is one of the motivators for why I want to teach ggplot in this PHI course, because it allows you to get fairly nice looking, compelling plots with a relatively small amount of code, and so you can get going on doing things relatively quickly and easily. So to wrap up, if you would like to make your data cleaning or manipulation life easier, you'd like to make really nice plots that are worthy of the New York Times or The Economist, this is where you'd probably want to start. I make no guarantees about your increase in coolness over the course of the course, but I'd like to think that you'll at least have acquired some skills that you can use in your scientific life going forward. I'm happy to answer questions now, or if you want to contact me by email, my email address is there. I just noticed that my Twitter handle is missing an N at the end, so that should be Dr. J. Wolfson. But that is all, and I think I'll pass it back for a couple of final remarks.
Yeah, absolutely. Thank you. So, thank you to Dr. Wolfson. We'd like to open the floor to your questions. Remember to type your questions into the Q&A box on the right side of your screen, and we'll get through as many questions as we possibly can in the time we have left. Okay, we're not seeing any questions coming through, so we'll go ahead and wrap up. Oh, we just had one come through. Will you have this course in the coming fall semester?
So this particular course, which is a 1-credit course, is offered through the Public Health Institute. There is a 2-credit course, which is called Essentials or Exploring and Visualizing Data in R, which covers some of the same material, but more material than is covered in this PHI course that is offered in the fall semester. So that is a 2-credit course that is offered in the fall semester. I see another question here. Are dplyr and ggplot already in our studio? So dplyr and ggplot are separate packages that have to be installed and loaded. And so one does need to install them before using them, yes.
Okay, with that, thanks again to Dr. Wolfson, and thanks to all who joined us to listen in on our Public Health Institute preview webinar. We hope you were able to learn more about the classes offered at the PHI, and we hope that you choose to join us at the Public Health Institute this year. You can find more information on registering for this class or looking into other wonderful opportunities we have at the PHI this year by going to our website, which you can see on your screen. And thank you all for your participation. Have a great rest of your day.